Hello friends, welcome to Code Sutra. In this video, we'll be solving Leetcode problem number 1489. Find critical and pseudo-critical edges in minimum spanning tree. Though this is a very difficult problem, I would say this is not a very tricky problem, but this is a tedious problem. And in this problem, there is two different concepts. And if you understand these two concepts, this problem which will actually be very easy to solve. So the two concepts are, the first thing is what is an MST? And how do we find an MST? And to understand this problems very thoroughly, at the end of the video, I have shared two questions and we have a dedicated Telegram group where we'll be solving these questions. So if you are interested, do consider joining the Telegram group. I have mentioned the link in the description. Now let's dive into understanding these concepts. What is an MST and how do we find an MST before we dive into the actual solution of the problem? Now, this is the actual input of the problem. That is, there are edges. There are 7 edges. 1, 2, 3, 4, 5, 6, 7 edges. And now let's look at what is an MST. Now, if you look here, is every city connected to every other city? For example, 0. Is 0 connected to all the cities? Yes, right. From 0, we can travel all the cities. Similarly, from 1, we can travel all the cities. And similarly, from any edge, we can travel to all the edges. Now, let's remove one edge. Let's remove this edge. Now, can we travel to every city from 0? Yes. From 1? Yes. We can travel from every city to every other city. So, this edge in a way was actually useless, right? Maybe the path cost increases, but we still have a path, right? From every city to every other city. So, this path was actually not required. Now, let's remove one more edge and see if the tree can sustain. If we remove this edge also, are the points still connected? That is, each city is connected to every other city. Yes. Now let's look at removing one more node. Let's remove this node. Is every city connected to every other city? From 0 we can go to 1, 2, 3 and 4. From 3 we can go to 0, 1, 2 and 4. From 2 again we can go to all of them. From 1 we can go to all of them. And this will be our MST. We cannot remove another edge from this. If we remove any one of those edges, these cities will become disconnected. Now, what is the condition of an MST? The condition is, if there are n edges, n cities, there has to be n minus 1 edges. This is a must and should condition. It is required. Just n minus 1 edges are required to connect all the cities. You cannot do with n minus 2 edges. And if you are using n edges or more than these edges, they will become unnecessary. So it is necessary that you will be having n minus 1 edges. Now there is a condition on top of this. So what is this condition? What is that condition? Say for example, let's assume this to be 4, and this path to be 2, Now the thing is, you can delete this node as well, this edge as well, and this edge as well. But which is the optimal edge to delete? This will be the optimal edge to delete, right? Why? Because the cost was higher in this case. So MST is not just defined by the number of edges. The number of edges will be same. MST is also defined by the cost. So now what is the cost of this? The cost of this MST is equal to 7. Similarly, there will be few other MSTs that is possible. Now we will look at how do we find an MST. Now let's understand how do we find an MST with the help of a beautiful example. The first thing is we have to sort the edges based on their cost. Why? Because the most intuitive thing for us to do is to include the edges with lesser cost, right? If you look in this problem, always we deleted the last edge, that is this edge. Why? Because its cost was very high. So the first thing that we'll be doing is sorting these edges based upon their cost. Now let's understand union find with the help of a story. Now there is a city, and there are 5 people in this city, and there is a huge war in the city. Okay, now what do they decide? Now 0 and 1 are coming together and they are forming a coalition. 0 and 1. Now they just can't form the coalition, right? Somebody has to be the head somebody has to be the leader and somebody has to be the follower. So now 0 is made as the head and 1 will be the follower, right? So that is the first edge. Now we go to the second edge. What does this mean? 1 and 2 are trying to form a correlation. Now the first thing we have to look is, does 1 and 2 belong to the same group or a different group? Now 2 is an individual person and 1 belongs to a group, but the leader of this group is 0. So what do? We associate this with this parent. So this leader, so now 2's leader will be 0. Now 2's leader will be 0. So this edge is also done. Now 2 and 3 are trying to form a correlation. Are 2 and 3 in the same group? No. Why? Because their leader are different. Who is 3's leader? 3 is itself 3's leader. And who is the leader of 2? 0. So what do? We bring 3 to the same group. That is, we will make 0 as the leader of 3 also. So this is also done. Now the next edge, 0 and 3 are going to form a correlation. Now is this possible? No, right? Why? Because already 3's head or leader is 0. So there is no need to form this correlation. So this edge need not be included in this. Now let's look at the next edge, that is 0 and 4. Are 0 and 4 in the same group? No, right? 4 has an individual and 0 has individual. So we will be including this edge as well. So 4 will also be coming under the same parent or the same leader. And if you look, all of them have already formed the group. Now this edge 3 and 4. Now who is the parent of 3? 0. Who is the leader of 4? 0. So we will not be including this. So this edge is not required. Similarly, this edge is also not required. Right? So now if you look here, how many edges did we use? 1, 2, 3 and 4. Just by using 4 edges as expected. Why? There are 5 people or 5 cities and all we require is n-1 edges. So we included n-1 edges and we formed an MST. Now what is the cost of this MST? 3, 4, 5, 6 and 7. So we were able to form an MST having a cost of 7 with just 4 nodes. Now you might be having a question, how did we decide the parent or the leader? The thing is, in this example, anybody can be made the leader of anybody. Say for example, 1, 2 is there, right? So now 2 and 3 are going to form a correlation. Now the question might be, who has to be made as the parent or the leader? Should 2 be made as the leader, or should 0 be made as the leader, or should 3 be made as the leader? Now 2 cannot be made as the leader, because why? We will find the leader of 2. Who is the leader of 2? The leader of 2 is 0. So this, and who is the leader of this group? 3. So we decide either 3 will be the head of all of them, 3 will be the head of all of them, or 0 will be the head of all of them. Both the cases are valid cases. Actually, you can optimize this, but for the sake of this example, we will be randomly doing it. That is, we will always choose randomly. That is, either 0 will be the parent or the next 3 will be the parent. Right? So that is what we will be doing. So how do we do this? Let's understand this with the help of an example. First thing, we will be having an array of size 5. Why size 5? Because there are 5 people. 0, 1, 2, 3 and 4. And this should have 1, 2, 3 and 4. Why? Because the parent or the leader of each one of them is themselves initially. Right? Now let's look at the first operation. The first operation is, we will find the parent. We will find the parent. Who is the parent of 1? The parent of 1 is 1 itself, and the parent of 0 is 0. Now what do? Since both of them are having different parent, we union them or we form a correlation. Now one's parent will be changed as 0, 0. Now again, say 2 and 1 are going to form the correlation. We realize that 0 is the parent and 2 is the parent. Now what we can do is, this will also be made as 0. Right? Now there is also other option, that is, this parent will be changed as 2. This parent will be changed as 2. That is, 2's parent will be no one but 2. Now if you look, now say 1 and 3 are forming the correlation, should it cause a problem? No, right? Why? Because if you look at 1, who is the parent of 1? 0. And who is the parent of 0? 2. So you will again land at the same leader. So we have the first method, that is find parent. What it will do is, it will find the ultimate parent. Say you are asking, whose parent is this? So it will be finding the ultimate parent. There will be one leader of this entire group and we'll be finding the ultimate leader. So that is what this method is doing. Now, the second method is the union method. What is this method? It will find the parent of these two. That is, say we are unioning 2 and 3. We are trying to union 2 and 3. What we will do is, we will find the ultimate parent of 2 and we will find the ultimate parent of V, and finally we will be changing the parent of one of them to the other parent. That is what we will be doing, so that now they have a common ultimate parent. So these are the two important methods how we will be forming or finding the MST. Right? Now let's look at what is asked in the question. This is the given question and this is the edges. This is the edges number. That is, this is the 0th edge, this is the first edge, second edge, third edge, and so on. Now if you look here, we just found one MST here. If you look, we just found one MST, but there can be multiple MSTs that can be found. That is, these are the 4 MSTs that are actually possible. Why is this possible? Why is this possible? If you look here, we included this edge whose cost was 2, but this edge can also come on top of this, right? Why? Because this is also costing 2, this is also costing 2, and even if you look here, these are also costing 1 and 1. So there are multiple MSTs possible since the cost is similar for few of them. Now these are the 4 MSTs that are possible. These are the 4 MSTs that are possible. What is asked in the question? In the question, you have to find the critical edges. Now what are the critical edges? The critical edges are those which must and should be included in every MST. So which are those edges? This edge, if you look, this edge is in all of the MSTs, right? That is the edge connecting 0 and 1. This edge should be in all of the MST, in this, and this. So now edge number 0 is one of our critical things. Now let's look at another edge which is present. This edge is present in all the MSTs. So 0 and 1. Is there any other edge which is present in all the MSTs? No. Right? So we will not be including. So there are just 2 critical. This is the first step of the problem. What is the second step? The second step is to find the pseudo-critical. That is those edges which are included in an MST but they are not compulsory. 1, 2, 3. This is one such edge, and we have 4 such edges. What is the number of those edges? It is 2, it is 3, then it is 4, then it is 5. Now if you look here, this edge 6 was never included in any one of them. So we will not consider that edge. These will be critical edges and these will be pseudo-critical edges. And it is asked in the problem, we have to return both critical edges as well as the pseudo-critical edges. Now let's understand how do we find this. Now the first step of the problem is to find one MST. I have just taken one MST here. We have just considered one MST. Now what is the cost of this MST? The cost of this minimum spanning tree is 7. So any tree which is having a value greater than this 7 is not a minimum spanning tree. So there are multiple minimum spanning trees, but all those values will be equal to 7. Now how do we find out? What is a critical edge and which are the pseudo-critical edges, right? So what do we do is, the first thing is we will ignore an edge. And try to find the MST. For example, we tell find as an MST, but avoid this edge. How do we do this? While finding the MST, we do a check. If this particular edge is included, we should avoid that. That is in this. For example, if this is the edge, please do avoid this particular edge. So what we are doing? We are doing the same operation of finding the MST, but we are adding one more condition, that is you should not include this edge. Now there will be 2 possible outputs. One output is you will not be able to form an MST. That is the first output. The second output is the cost of this MST will increase. Right? In both the cases, what does this indicate? This indicates that this is a critical edge. Now, if you are neglecting this edge, that is you are saying this edge should not be included and the MST value does not change. Does it mean it is a critical edge? No, it doesn't mean that it is a critical edge. Similarly, if you are blocking this, that is you say this edge should not be used And if it doesn't change the MST or one more MST can be formed, then this is not a critical edge. This is how we check a critical edge. That is, we will be blocking a particular edge and we try to find out the MST once again. And if the MST value increases, or if there is no MST, in that case, that will be a critical edge, which indicates this edge must and should be indicated. This is the step how we will be finding the critical edges. Now, how do we find the pseudo-critical edges, right? To find the pseudo-critical edges, what do? We say to the algorithm, the same MST, that this particular edge should be included in this problem. Should be included in this problem. So what happens when we say this should be included? When it says we should be included, this is the first edge or the first correlation that will be formed. That is 2 and 3 will be the first correlation that will be formed. Even before considering the 0th edge, first edge, second edge, we will be forming the first correlation as this correlation. So once we are formed this correlation, then only we will proceed with the next correlation or the next union, right? So once we are doing that and finding the MST once again, the value should not increase once again. What does it mean if the value has increased? It means that this is not a pseudo-critical edge. This is not a pseudo-critical edge. Now the value has to come out as the same. The value has to come out as the same. If the value has come out as the same, that is equal to 7, then this will be a pseudo-critical. Right? This will be a pseudo-critical. And the thing is, this and this should not be overlapping. Say for example, one of them is considered as a critical edge, then this same edge should not be tested for a pseudo-critical edge, right? Because this is a critical edge, and even if you are sending it for a pseudo-critical edge, it will be given as a pseudo-critical edge. But the thing is, once you have found out an edge to be a critical edge, you should not check for if it is a pseudo-critical edge or not. Let me repeat the step once again. The first step is to find an MST and the value of the MST. We found it out to be 7. The second step is, we will make an edge compulsory. That is, this edge should be included. So how do we do that? This edge will be we will block this edge. That is the first step. We'll be blocking this edge, saying that this edge should not be included. So once we say this edge should not be included, what do? Whenever we encounter this edge, we skip this edge, right? So now there are two outputs possible. One output is, we will not be able to form an MST. That is, there are still two groups, that is, there are different parents. The second output possible is the MST value either increases, right? If it is increasing, then this is a critical edge. So we will be adding into our critical edge. This is the first step. The second step is, we will be forcing an edge. That is, we will say this edge has to be included. How do we force this? That will be the first edge that will be formed in the correlation, right? So once we have forced an edge, again, there are two outputs. One is the cost increases. If the cost is increasing, that will not be a critical edge. If the cost stays as the same, then it will be our pseudo-critical edge, and this can be added into pseudo-critical edge. Now let's look at the pseudocode for this problem. Now let's understand the pseudocode of this problem. The first thing is, we will create a list of critical and pseudo-critical list. Both of them will be empty initially. The second thing we have to do is this, sort the edges. But we should be careful because we will be losing the index once we have sorted them, right? So we will be attaching indexes to the edges. That is, say for example, this is the given edge. This is the given edge. But what is the index of this? If this is the index 0, we will be attaching this. Why? Because we should not lose this value, and this is what should be added to both of the lists. So we will add this and we will be sorting the arrays in the first step. Then the second step is to find the MST. I will explain the function of find MST, but the first step is to find the MST. And what does -1 and -1 indicate? That is, we are not blocking any road, or we are not blocking any edge, or we are not making anything as compulsory. Now, once we have found the MST cost, then what we will be doing? For every edge, the first thing is, we will try to exclude this edge. That is, we are excluding this edge. That is, we are blocking this edge. And if the cost increases, what does this mean? This means that it is a critical edge. So we will be adding the index to the critical edge. Now, if it is not a critical edge, only in that case, we will make this edge as compulsory. We will make this edge as compulsory and we will check the cost. If the cost is same, we will be adding it to the pseudo-critical. However, if the cost is more, it is not a pseudo-critical edge, right? So we will be adding it if the cost is same. Finally, we will be returning the critical and the pseudo-critical edges after combining them. So this will be our answer. But now let's look at the find MST function. Now we have edges, and on top of that we have a block and include. This indicates that we have to block this particular edge, that is we should not include this edge, and this indicates that we should include this. And if it is equal to -1, which means we are not specifying anything, that is in this case we are not specifying anything. So if it is not equal to -1, the first thing that we will be doing is union of that edge. Suppose this is the path, then what we will be doing is we will be doing the union of this first and we will be increasing the cost. That is what we will be doing. Then only after that we will be doing the same thing. We will be checking for all the edges if that particular edge is blocked or not. We have a blocked index also. We will be check if that particular edge is not blocked. Then what we will do, we will find the parent of both of them. We will find the parent of 0, we will find the parent of 1, and if both of them are having the same parent, we will not do anything. However, if they are having different parent, so what is the option? The option is to union them, that is connect them or form a correlation. Now, even after forming the correlation, we have to check one thing. Who is the parent? That is the ultimate parent of all the edges. See, this might also happen. 0, 1, 2 are connected, and say 3 and 4 are connected. This can also be one of the case. Now if you look, the parent of all of them are not same. Which indicates that we are not able to form an MST. So in that case, we will be returning integer.max value. So this is a dummy value. We can just return MST plus 1 also. That will also work, but we will be returning maximum value. If not, we will be just returning the actual cost of this MST, where it will be checked once again and compared, and it will be added either to the critical edge or pseudo-critical edge. Now, if you are not completely able to digest this problem, these two problems are very similar to this. That is, this is one of the MST problems and this is again a union find problem, and these two are very medium level problems, so that you will be able to understand this very quickly. And I have also mentioned a Telegram link in the description where we will be discussing about these problems. So please do consider joining our Telegram community. Thank you for watching the video. Please do like, share and subscribe.